So here we're running the LGMV software on the outdoor units to just data log what the room, I'm standing on top of the room. This is one thick foam. This is actually a freezer box. And so there's 100 lights inside this room. And we have the 4 6-ton air handlers on the outer corners. And then we have the 2 8-ton air handlers on the inner part going down into the room. And we want to add reheat, where we add a second coil, and you can either use DX, where you'd be using an expansion valve hot refrigerant gas, and you would actually putting like a heater. You'd basically be running the hot gas back to another coil in front of your air handler. So your air handler produces the cold, but that is too cold and it will overcool the room, and you want to do more dehumidification, and you want the air handler to stay on longer. You don't want it cycling on and off. So you would chill down your coil to a lower temperature to its optimum rate to make as much moisture as possible. You're going after the latent heat. You're not going after the sensible heat. So you're turning your coil in a little bit more favorable for latent heat, but that would normally over chill the room, and you would have a very unsteady room temperature, and you would over chill the room. It's a bad situation, especially when you're growing cannabis. And different parts, a room for cannabis is very dynamic. It changes over the weeks. How much water is respirated out of the plant changes week by week as the plant grows, and then as it hits end of life and it stops drinking, it stops respirating, and your different feeding regimens, it depends on how many looms of light you're hitting the plant with and how much they're respirating, and your operating temperature, because there's the guys who are in the camp of higher temperatures are better, and then there's other guys who like lower temperatures. There's very few of those guys, but they are out there. You have the guys who like to stay in the 80s. Then you have guys who like to grow their plants in the 70s. And there's guys who even grow, and I know about, and it works really good, but very few people can do this. There's guys who literally grow their plants somewhere around 64 degrees from the beginning of the cycle of week 1 to the end of the cycle of week 8 or week 10, depending on what it is. And everyone's going, what the hell? Yes, it works. And there's a method to that science, and there's reasoning behind it that I won't go into. I've done it before myself, so I know about it. Don't go that route unless you can afford to experiment. Okay, so let's get into this. Different plants display around. So in this room, when they first started this room, their very first cycle, their very first crop, they were using their same methods that were used in other rooms that were similarly set up, but not like this one. And the output of water per day on this room was somewhere around 125 gallons of water in one day wet spraying, where 1 500 to 2 500 pint dehumidifiers were capable of holding the humidity at somewhere around 50% when you wanted it at 50%. Most of the time, if you're doing VPD, the vapor deficit, whatever it's called, the higher humidity levels, you don't need that much. But when you needed it, it took 2 500 units. Well, now we have 3 500 units, because now they're much more healthier, and instead of being around 1 pound per thousand, we're approaching 3 pounds per thousand. And so now we have a much thicker canopy, more leaf surface, and more looms, and we're uptaking more water, so we're putting out more water, so we have to remove water. So the same room that was doing 125 gallons of water a day just in condensate water between the dehumidifiers and the air handlers, we're now doing 250 gallons of water, of condensate water, out of this room every day. And that's why plants are not a static load throughout the growing season. It's different temperatures, different humidities, different respirations, and all that takes different methods of attacking the same problem. So we have to make a very dynamic change. So what we're going to do here is we're going to use the waste energy that you already paid for to cool this hot air developed by the lights and the dehumidifiers. Remember, you have like here a 500 pint dehumidifier. This thing's putting out about 4 tons of heated air into this stream of air that's 6 tons of cooling air. So all this thing is doing, you are literally adding more heat back into the room, and you got to pay to cool that. Dehumidifiers are more efficient at removing water than air handlers. But when you get this ridiculously big and large and you have to run them all the time, it gets pretty ridiculous and expensive to start installing them. Now, when you want to install this stuff inside the room and you have no room like we're going to in the other rooms, all this is going to be hanging from the ceiling inside the growing room. So there's no room for this kind of stack. There's not that much room. There's only 3 or 4 feet of head clearance above the rolling racks that are going to be 12 to 16 feet high. So this needs to be shrunk down or eliminated, or a few of them. These need to be shrunk down. So what we're going to do is we're going to take the waste energy heat and we're going to either use hot gas back to a second coil in front of the cooling coils, or glycol loop, and use the energy that you spent. You paid money to PG&E, the energy company, to cool off the rooms. That is wasted energy, and that energy just goes out the hot pipe and it gets spewed out to the atmosphere through the fans. So what we're going to do is we're going to grab that heated hot gas and pipe it back into a second coil and drive the air handlers a little longer, harder, and a little colder to remove more moisture to compensate for some of these dehumidifiers. And we probably won't be able to eliminate the dehumidifiers, but all that free energy is going to be used to remove more moisture so we could get much smaller and fewer dehumidifiers. So instead of having these big 500 pint units, I'm hoping we could get down to somewhere about 125 pint to 200 pint units, somewhere in that range, so I could be half the size and I could hang them from the ceiling within a small room all together and have room left over, and use that energy that was wasted to the atmosphere for dehumidification. On top of that, then you take all the wastewater, which in this room is 250 gallons a day, take that wastewater, put it through the water purification system, and use it to re-water the plants with. So say we're going to have 10 of these rooms in this location. We're about to set up the other couple rooms. Say you have 10 identical rooms like this, producing 250 gallons of water a day. Instead of going down the drain, you reuse it to water all your plants. Now, if you live in a place like in California and San Francisco where water is very expensive, that starts to play a role in the long term. That's a long-term gain kind of thing. So if you have 10 rooms just wasting 250 gallons of water right down the drain away, wouldn't you rather take that 250 gallons of water times 10 and put it right back into the rooms again? So that's what we're going after here, is recapturing all the energy, reusing it, not spending more energy on dehumidification, decreasing the size of the equipment, decreasing the labor is basically the same. Whether you have a 500 pint unit or you have a 200 pint unit, you still have the same labor, less materials, smaller materials. But to wrap this, to set up the sheet metal, to put it in place, you're using the exact same procedures as whether it's a 1,000 pint, 500 pint, or a 200 pint system. That doesn't change. Your materials goes down, and the number of units. So say we need 4 units, well, maybe we could get away with 2 units. You know, it all depends. So that's what we're shooting after right now. So I also have to go around, and what I do, you go around and take a water sample for 15 minutes or an hour of each dehumidifier. You can see where I have the coupling, and I break them off right there. And when they're running, I take a sample, you use your stopwatch, and you see how many pints come out or how many gallons come out in 15 minutes, a half hour, an hour. And you do that for each one, and you could find out exactly how many gallons or how many pounds of water are being removed by every dehumidifier from your crop. And you do the exact same thing for the air handlers. And then there's actually, you know, with mathematical formulas, you can figure out by the poundage and your temperature you want, you could figure out how much reheat you need for your coils to efficiently remove water and do the job you want with fewer dehumidifiers, with less energy spent and less materials. All right, guys, I'll catch you later. Got a couple more hours of data logging to do. See ya.